All right, let's do it. Hello and welcome everybody to the next webinar series, FLATE Webinar Series. Today we're going to talk about the role of robots and artificial intelligence in Industry 4.0. We'll get to that just in a few minutes. But just wanted to welcome everybody. I know I saw a few faces that I know and a few that I don't. So welcome all. All right. Next slide. Okay, so just a quick update for those of you that haven't attended one of the webinar series or aren't that familiar with FLATE. The goal of FLATE is to drive Florida's world-class manufacturing workforce education and training. And we do that by curriculum reform and development, working with all the colleges and state colleges in Florida that have manufacturing related degrees, ET degrees, as well as we do a lot of outreach and student recruitment, professional development, which we're doing today, and technician education research, which Dr. Barger has some really nice grants that are doing some great research using LIM projects and some other equipment. So our goal is to impact locally and reach nationally. So these are some of the colleges that we work with that have ET degrees across Florida. You can see we cover the whole state of Florida, and we're really happy to be able to work with all the great staff and faculty at these colleges across the state who are creating some really good ET degrees. All right, so some of the activities that FLATE does is we do a lot of outreach activities. We go to a lot of work with RMAs, which are our regional manufacturing association. So most all large communities in Florida have an RMA, and we work with them as well as directly with schools, educators, do a lot of conferences, and just try to get the word out about how great manufacturing is as a career option. We also do help develop curriculum, working with the schools in the ET Forum. We help promote and update the latest curriculum. We also do the FLATE Manufacturing Awards, which just closed, but those are some annual awards that recognize the best of the best here in Florida. We also have the ET Forum, which is coming up next week. So if you would like to go and haven't signed up for it yet, you still can. So please take a look at that. It's a 2-day event where all the schools that have ET programs come together, and we talk about collaborating and how we can make it better for all of us. We also just created a data dashboard that we're really proud of, and we'll show a snapshot of it here in a second. But it's certainly becoming a great tool to use for parents, teachers, industry, and schools to identify what's out there now as it relates to manufacturing, and also some opportunities to connect. And we also have some great mentor programs helping schools or teachers or industry get together and work more collaboratively. All right, so you're in one of our webinar series, the FLATE Webinar Series today, coming up on April 18th. There's one on creating videos using classroom projects and success stories. April 26th, how to increase student diversity in ET programs. May 10th, this is a great 4-part series. This will be the last of the 4 on May 10th, cybersecurity and manufacturing. All of these you can catch if you missed them live. We have the recordings up, and I don't know if we might put a link to that as well, but you can certainly catch all the past webinar series online. Okay, so other events. I just talked about the spring ET Forum next week in Daytona. Please sign up if you haven't. There's a FANUC workshop on April 20th in the College of Central Florida. And then in June 12th to the 16th, we're doing a FLATE Summer Teacher Institute in St. Pete College. All of these things can be found on the FLATE website, I think under events. So if you'd like to find them there, you can register for all the events that are posted here. Okay, so FLATE over the years has created so many great resources. These are 3, the FLATE.org, Made in Florida, and the Wiki, all great resources. And also there's the monthly newsletter that you can catch with that link down below. And I think the next slide has a snapshot of our new dashboard, certainly another great resource. Please take a look at it. You can get to it many ways. One of them is manufacturingmattersfl.org, or you can go to the FLATE website and get the link from there. But yeah, please check it out. We'll talk more about it at the ET Forum. But check it out. And if you have any comments, please let us know. We certainly, our goal is to get something out, which we did. I think it looks pretty strong, but our goal over the next few years is to make it a more valuable resource for the entire state. Okay, so these are some contacts. My name is Ernie Friend. Most of you, if not all of you, I'm sure know Dr. Marilyn Barger. We also have Daniele and Teresa. We are the team. We are the FLATE team, and we cover the whole state, and we're here to help you be successful as it relates to manufacturing, education, and outreach. All right, so without further ado, I'd like to introduce Dr. Miri from Polk State College. He's the professor of engineering technology, and we are really excited today because he's going to talk about the role of robots and artificial intelligence in Industry 4.0. Take it away, Dr. Miri.
Hello, everyone, and thank you for being here. Let me see if I can share my screen. I'm not as experienced in Zoom as you are, Ernie. Do you see my screen now?
Not yet.
Not yet.
Don't see it yet. No.
Okay, sorry. I did
Yeah,
share screen.
Yeah.
Okay.
If you're not familiar, at the very bottom there should be a green share screen button.
Yeah, I clicked on that. Who can share? Oh, okay. Oh, participant. Because it said who can share. It's okay. Share.
Okay, we can see it now.
You can see it. Oh, good.
Yeah, probably just want to put it in presentation mode. You know how to do that? There we go. Perfect. All right, thank you.
Is that good? Okay. So these images are, I guess, blocking. I move it. Okay. So, Industry 4.0 is a new movement in manufacturing, and it's growing and it's still evolving. So it's the right time to be asking questions of, what should the role of artificial intelligence and robots be in industry for the fourth industrial revolution? And the Industry 4.0 became a serious movement in 2016 when World Economic Forum opened its Center for the Fourth Industrial Revolution in San Francisco. And in the big picture wise, it conceptualizes fully integrated and automated factories where the enterprise operational data is seamlessly available to whoever or whatever that needs it in real time. That's the big picture, and you will see soon that the integration level that is talking about is much higher than anything we have seen before. It's fully integrated, and they mean that. Before we get to the specifics of what are the Industry 4.0 objectives, and we want to talk about how artificial intelligence can play a role. Let's look at what artificial intelligence is first before we can decide how it can contribute to Industry 4.0. Artificial intelligence is currently defined by most computer scientists and ChatGPT as the ability of computer programs and systems to perform tasks typically requiring human intelligence. So I'm going to show you a 48-second video, and then let's decide if this act of this robot is artificial intelligence or not. Because we want to have a clear idea of what artificial intelligence really is. So here's a robot that is setting up, in the middle of the video, is setting up a domino and then does a little dance and then knocks the dominoes down. I just want to make a point in this video that what is really is considered artificial intelligence. What's something that's not artificial intelligence is clearly obvious, but what is considered artificial intelligence is not as obvious. So this robot is going to do a little dance, and I want you to pay attention specifically to how the pieces of the dominoes were served to this robot in that 3D printed tray. it's a green one sitting on there. The pieces of the robots, of the dominoes, were presented to the robot in a very specific location and with very specific orientation. So everything that this robot did is pre-programmed. Everything that it did pre-programmed. There is absolutely zero intelligence is what this robot just did. What would be in artificial intelligence if the pieces of the robot and pieces of the dominoes, instead of being served in a tray like in the perfect location, you throw the pieces randomly in front of it. And if the robot can still do this domino act, then I would consider that artificial intelligence, because it has to take pictures, it has to know where every piece is exactly, what orientation, and then translate that information into controlling its actuators to go with end effector, go and pick each piece precisely. That would be artificial intelligence, because there is no way to pre-program this robot to do that, because you're randomly throwing the pieces in front of it. There's no way to pre-program it to do that. It has to have an artificial intelligence algorithm to figure it out on its own. So that's what the artificial intelligence really means. Now we're getting to a specific of the Industry 4.0 objectives. First objective is, no matter what you're doing, that's always the objective. To do more with less. I mean, that's whatever you do, that's always the objective. And that's also one of the main objectives of Industry 4.0, increase productivity, reduce costs. Then it's a connectivity. They envision that all the devices, equipment in an enterprise is connected to the company's network, and its data is being collected in real time and provided to whoever or whatever that needs the data. Usually the consumers of data are not people. Consumers of data are other computer programs, typically. But if people want to look at the data, they can. But typically in an automated system, people are not the consumers of the data. And that, yeah, we'll get to that. That is automate just-in-time inventory management. With all the data that you collect, and it should be possible to manage your inventory just in time, so you eliminate the need for large warehouses. And then detect abnormal conditions to prevent industrial accidents. In the picture you see on this image is a transformer fire at a power substation, and that's such a common occurrence. It's not a rare event. Transformer fires happen often. And one of the main goals of Industry 4.0 should be to prevent, with all the data you're collecting, you should be able to know that transformer is getting hot. You issue a work order and send the maintenance people to quickly see what's happening. So that's one of the main goals of Industry 4.0. It should be. I mean, it is still evolving. So if you go to Industry 4.0 community, you don't see much talk about preventing industrial accident. That's my personal opinion. That unless you have this component of Industry 4.0, in my opinion, Industry 4.0 will not be even a revolution. It will be an evolution of Industry 3.0. This is the component that makes it a revolution, because it's so, industrial accidents are so costly in terms of lives, in terms of assets. And one of the metrics that is used today to measure manufacturing efficiency is called the overall equipment effectiveness. Today, that's a very hot number that every manufacturer brags about their number. It's called OEE number, overall equipment effectiveness. This hypothetical equipment you see here is showing the OEE number of 24%, which means, this equipment was scheduled 953 times to produce a product. Out of that 953 times that was scheduled to produce, it only produced 239 times, because the other 714 times it was not available to do for some reason. Equipment was unavailable. For most, on average, manufacturers' OEE number is less than 50%, except for Tesla. Tesla brags an OEE number of 90%. So one of the objectives of Industry 4.0 is to reduce equipment downtime. Figure out why the equipments are not available when you need them, and try to reduce that downtime. Reduce scrap and reworks. Scraps are so much waste that happens. You scrap that manufacturing generates that cannot be used, and the bad quality, the parts that are made with low quality have to be reworked. That is, so if you, but with all the data you collecting, you should be able to, improve the quality of your operation, so you don't need to rework parts and you try to minimize the scrap. That's another objective of Industry 4.0. And improve product quality, of course. Again, once you improve your product quality, and you won't have a lot of rework rates. And remote monitoring, that's also a big objective of Industry 4.0. They want to be able to remote into the manufacturing plant operation and monitor it remotely and control it remotely. So a plant operator can be anywhere in the world that has internet access and remote into its operation and run whatever he needs to do remotely. So what's the Industry 4.0 framework that your infrastructure needed to make it happen? Because that needs collecting data. Vast amount of data requires a solid infrastructure. The five boxes you see on the right, those are, if you just look at the 5 boxes on the right, that's Industry 3.0. That's the infrastructure the Industry 3.0 brought us. The third industrial revolution brought that infrastructure to us. At the bottom, you have what they call the edge devices. You have your PLCs, you have human machine interface devices, sensors, actuators, robots. Anything that's on the factory floor, they call the edge devices. That's the edge of your network. And on top of that sits a supervisory control and data acquisition. A SCADA system sits on top of that monitors some of, not everything, some parameters of the edge devices and controls some devices on the edge. Not all. Then on top of that, you see manufacturing execution systems that where you the work order, they get the work order and then they schedule equipment to produce the part according to the work order. And then you have enterprise resource planning. That's where the work order is generated. That's where all the resources are distributed. That's what the accounting ties into. So that's called the IT part of the enterprise. The first three, the bottom 3 blocks, edge devices, the SCADA, manufacturing, MES, they're called OT, operational technology. Above that is called information technology. And one of the objectives of Industry 4.0 is to integrate these 2 things together. In Industry 3.0, the data moves linearly so the data that's generated on the edge devices can only be controlled, monitored by, or collected, not all of it, even some of it by the SCADA system. Anybody who needs the data, you have to come and get it from the SCADA system. And another thing is that in Industry 3.0, the machinery involved in producing something is controlled locally without regards to what else is going on, is running in the company. It's what we call the islands of automation. Industry 4.0 tries to integrate it so there are no islands anymore. Everybody knows what everybody else is doing. And they do that by adding this box, orange box in the middle that you see called unified namespace. That is the box that distinguishes Industry 3.0 from Industry 4.0, which means the idea behind this unified namespace is that now everybody sends their data to this space, which is another computer program. So all the devices on the edge, they send the data to UNS, manufacturing execution, any component that's a part of the enterprise resource planning, everybody who generates data must send it to this workspace. They say publish it. It publishes to this unified namespace, and anybody who needs the data, any kind of data, they subscribe to the data. So if somebody wants to know temperature, subscribe to temperature, they say, I want every temperature data in the operation comes to me. You subscribe to temperature. And then the unified namespace sends the data of the temperature every time it's changed, it sends it to that subscriber. It's called the pop-sub model. So that's the difference. The data doesn't move linearly. Data is available to whoever subscribes to any topics. So the data is received with identifying tag. They have, depending on which UNS you pick, then there's certain specification that your devices, your clients must follow before they can send the data to the UNS. But in general, this is one model of the UNS, which is called MQTT. It says message queuing telemetry transport, where it's a data broker, where you can see the green boxes, those are the edge devices, robots, sensors, actuators, PLCs. They publish their data to the broker. Some clients are just publishers, some problems just subscribers, some clients can be both, but they publish and subscribe. So if you have a sensor that's smart enough, because the MQ, whatever the broker you pick, it has its own data formatting requirements. So any data you send to it, it has to be formatted according to its specification, which usually means you have some header bytes, then you have the payload, but the header bytes are very specific what it should be. So if, most sensors we have right now, they are not Industry 4.0 compatible. So if the sensor is already compatible, then you can directly publish to the broker. If it is not, usually you can you get a PLC that's compatible with the MQTT, and the sensor data is collected by the PLC, and then PLC will send the data. So you don't have to change all your sensors. You have to change all your PLCs, however. The PLCs that are not compatible with Industry 4.0 will not work in this model. And then the clients, of course, anybody can be client of this broker, enterprise resource system, manufacturing execution system, warehouse management system. Any client can be subscribed to this MQTT data. And the beauty of this model is that if you add a new edge device, you add a new temperature sensor, nobody has to update anything. It's automatic. It's called edge driven. The data temperature is sent to the MQTT broker. Anybody who already subscribed to temperature is going to get this new temperature data with its tag, what it is, automatically. The PubSub model, this model of PubSub model is the most suitable model for Industry 4.0. There are other models that are pushed by very well-known companies that I tell you will be surprised. Everybody, because the best-known company in the world, they are pushing other models, such as OPC UA, so Open Platform Communication, Universal Architecture, that in my opinion, and some other people who are hands-on in these things, if you pick those brokers, but there's not sub-pub model, they don't follow the sub-pub model, they follow the poll response model. And anybody who has tried to ever collect data by poll response of devices, it will tell you that as the number of devices grow, the time it takes to poll every device is going to be so long that you are no longer in real time. So any large companies that buys into this push that adopt other technology other than the sub-pub model, it will be a strategic error in my mind. There is no, at the end, they will really reach a dead end that it's not scalable anymore. So if you want something that is scalable to millions of clients and millions of topics, because you have millions of clients or the nodes that connect to this, actuators, any client that sends data or subscribes and publishes data to broker, there are also topics that it has to manage. So people can subscribe to different topics, temperature, pressure, flow, whatever they want to subscribe to, they subscribe. And it has been shown in the recent tests, the last few months, one MQTT broker software manufacturer, they demonstrated that it can manage 200 million topic subscriptions. That kind of a scaling you cannot get with the OpenCU or any other technology. That should be by now obvious to people, but still some people seem to be ignorant of this simple fact. So it's not only millions of nodes, but also millions, hundreds of millions of topics that people can subscribe to. And then this part of the Industry 4.0 that you see on this picture, this part of it is called the IIoT, Industrial Internet of Things. That's just a name they give this part. This provides the connectivity of all devices and clients to the company's network. So IIoT is the infrastructure that enables 4.0. The IIoT provides the connectivity, and what are this is just in MQTT will tell you how to format your data, but the delivery of the data, you send the data, somebody has to assure you that data gets delivered to the intended consumers of the data. So that's not part of the, I'll tell you about that. I got ahead of myself. Okay, so application So what are the IoT Industry Internet of Things, that this infrastructure required for Industry 4.0 to collect all the data that they need is, you have at the application layer, you have the edge devices, sensors, PLCs, robots, HMIs, etc. Transport layer is MQTT or OPC-UA that I favored MQTT. And it is an example of software that already existed. HiveMQ is the one who just did a test of 200 million topics. And then EMQX is, because the Chinese, it's also good, but people don't want to avoid China, like these days with Chinese technology. So HiveMQ is becoming preferred choice at this time. But the other option, I'm just saying these are the most famous options of MQTT Pro. These are other computer programs. OPC-UA is Open Platform Communication Universal Unified Architecture. That's being pushed by very well-known companies because they put all the investment and invest in this technology, and they're not pushing it very hard. That's a poor response model. And then transport layer, they use as TCP, Transmission Control Protocol, which you're already familiar with. That's TCP protocol assures the data gets delivered to the intended recipients. That's separate from MQTT. That's the technology is already there. It's handshaking technology, which is already there. And then the internet layer. So the data, there's many apps can be running on laptop or desktop computer that consume the data that the broker sends them and do whatever they want to do. There are many apps the company may want to run with this data. It will be other software, and these are some very famous ones: Ignition, HiByte, Maneo. These are very famous, what we call internet layer of IoT. And then there's the cloud layer. I put the cloud in quotation because it may or may not be cloud. Cloud basically means the computer resources that you rent, you don't own, managed by somebody else. You call it cloud. You can have your own computer resources and don't call it cloud, but you can do the same thing. So then we have Amazon Web Services, Microsoft Azure, HiveMQ Cloud. There are a lot of people you can rent computing power from. But there's a computer layer at top that if you need higher computing power, that you want to develop machine learning models of your equipment, that usually done at the cloud layer. You send the data to the cloud layer because those things are computationally extensive. Yeah, I was trying to say. Yeah, we can talk about machine learning later more. So now that we know something about what Industry 4.0 wants to accomplish, let's look at the role of artificial intelligence in Industry 4.0. Artificial intelligence is this blue circle is the broad field, and the subfield of that, which is suitable for manufacturing, is machine learning. Machine learning is the subfield of artificial intelligence. And usually what machine learning do, again, I guess machine learning is defined by ChatGPT as the development of algorithm and statistical models that enables computers to learn from data, recognize patterns, and make decisions or predictions without being explicitly programmed to do so. So that's a common understanding of what machine learning is. So machine learning develops input-output model of your equipment. And usually the models are neural network models, typically because shown to work better. And then, neural network models, basically you're relating input of the machine to the output of the machine. You want to understand this machine well. Then you give it, once you have established that correlation between input and output, then you give it any input, they will tell you, machine learning will tell you what the expected output is. If it is not what you expect, then there is an anomaly. And this concept of deep learning, you might have heard about it, is really not a huge concept in my opinion. It's just that neural networks have input layer nodes and an output layer nodes, and then in between they have hidden layer nodes of hidden layers. And depending on I think it's three. If you have 3 or more hidden layers, they call it deep learning. It's the same model, it's just more complicated, it's more sophisticated model. They just give it a new name. It's just neural network model with more layers. It's called deep learning. So machine learning wants to learn as much about as a machine as it can. Then they can use the model to predict the future behaviors that result from any system input. And another thing about machine learning, as it's collecting, because it's constantly collecting input-output data, to see for any even an input, this is the output you should expect. If the output is not what you expect, there's an anomaly. But as they collect in this data, they better their own model. Because they have new input output model, they can fine tune the model they have. They improve their own model. So knowing how industrial systems are supposed to behave, and no system have the ability to detect anomalies and prevent industrial accidents. So, and it requires a lot of machine learning requires a lot of data, training data to be collected from all equipment that you want to have a model for. And data is collected by the IIoT infrastructure, and applications are running in cloud layers subscribe to the data they need. So that's another beauty of this Industry 4.0 thing, that sub-pub model. You don't have to, like the old, right now, probably if you want to send data to the cloud, you have to either export an Excel sheet. Usually, right now the data is automatically. Cloud applications subscribe to the data they need. Automatically, the broker sends them the data they need for them, whatever purpose. In this case, we're talking about machine learning. Yeah. So, many industrial accidents happen because of absence of sensors or failures of existing sensors or actuators. This picture you see here is a train derailment in Sarasota, Florida on April 28th of this year. I mean, and that was not on the news because, the Ohio train derailment was in the news. But train derailment is a common occurrence. There are over 1,000 train derailments. With all the data that now you collect with Industry 4.0, you should be able to prevent accidents like that. Otherwise, if that's not one of the main goals of Industry 4.0, again, I would not call it a revolution. It's just an evolution of Industry 3.0, where you collect and distribute the data a little better. But so to me, this should be one of the main focus of Industry 4.0, preventing industrial accidents. It's very costly in terms of lives and assets. So, yeah. So I wouldn't separate the machine learning from, so with that philosophy, I would say that machine learning is an AI application that is facilitated by Industry 4.0, by IoT infrastructure, and should be an integral part of it. So when we say Industry 4.0, we assume that ML is part of it. Just data collected. How do you detect, abnormal condition and prevent accidents? Like human beings, when we get sick, we have symptoms, right? When machine gets sick, they have symptoms too. But unlike biological being that we have self-healing abilities. Machine don't have self-healing abilities. Once machine demonstrates symptoms of a problem, it will eventually lead to complete failure. But the symptoms can be detected. If you have collecting all this data, then the symptoms of a machine can be diagnosed, can be picked up and diagnosed, and you can automatically, and Industry 4.0 envision this, you automatically issue a work order to maintenance department. The maintenance department goes to look at it. It all happens automatically. That's the vision of Industry 4.0. So this is our own liquid process control system, designed and built by our own Dr. Tusi. This is an example. This simple, relatively small process has over 20 sensors that make it operate. And I'm just trying to say how a machine learning can prevent failures. That's a good example, and we're hoping to implement machine learning on this system. If you're measuring your pressure along a pipe, 2 different points in a pipe, this has pressure sensor, flow sensor, temperature sensor, level sensors, kinds of sensors, and actuators, over 20 actuators, solenoid pumps. And if you're measuring, pressure along this closed loop system, 2 different points, those pressures are correlated. If you're measuring temperature, same thing. If you're measuring flow rate, the same. They are correlated. So you have redundancy of the sensors. You correlate the sensory data, and if one sensor is showing an operation parameter being outside normal condition, and all other sensors showing no, everything is okay, then you can say, okay, this is a sensor failure, it's not a process failure, it's a sensor failure, or vice versa. If more than one sensor showed something is wrong, then you know something is wrong. So that was a role of like artificial intelligence, as far as I see it, is machine learning. Machine learning can contribute greatly to Industrial 4.0 and make it a revolution. Without it, it's not a revolution. So machine learning, artificial intelligence role in Industry 4.0 is critical. The role of robots is now talk about role of robots in Industry 4.0. Robots have always, have been increasingly deployed in manufacturing automation for decades. And they're going to continue to do that. And they have replaced humans from many repetitive and hazardous work. But with the Industry 4.0 goal of more automation, robots will naturally increase, but still they contribute to automation. Collaborative robots or cobots can work collaboratively with humans at the application layer of Industry 4.0 to improve production efficiency. Collaborative robots are robots have the sensors that when you run into something, they know it and they stop, pause. You can decide what happens after a collision. The robot collides, a collaborative robot collides with something, you can program it what to do. You say, okay, restart after 10 seconds, or completely stop, or send a signal, or do whatever you want. You can program what to do. But that's why they call it collaborative. You can work in close proximity of them and not get hurt. And they also can communicate with each other. But of course, everything, if you want to integrate everything with Industry 4.0, they have to be compatible sensors. Robots right now don't have a Industry 4.0 sensors mounted on them. If you want to be part of Industry 4.0, it goes for your PLCs, it goes for all the other devices. They have to be compatible with Industry 4.0 data broker, which, there's some things you may not have changed. Again, I did say that earlier, that, PLCs can be the middle person that collects the data and put them in a compatible form, but then your PLCs have to be compatible. Right now, there are a lot of PLC manufacturers I'm not sure if Rockwell is, but a lot of other PLC manufacturers are doing that. I'm making PLCs that are compatible with MQTT brokers. Up to 22 PLCs are one of them. That I think they were pioneering that. Yeah, robots can help collect. IoT infrastructure needs to collect a lot of data. Sometimes you cannot mount permanent sensors. Robots, because they have mobility, they can go and help you collect data. And robots also can communicate with each other. As I will show a demo. Our folks that run a demo with robots coordinating their activities with each other, because robots are like other devices, but they're smart. They've got to have a computer on them. Yeah, I'm just saying that if you want to develop machine learning software, you need a lot of data. I'm just saying that robots can help you collect that data. And then, I guess this is just something in saying that sometimes you collect anomalies. Anomalies don't require quick action. There's no time for issuing a work order to send the maintenance. Some transform is getting hot. You need immediate action. In that case, you program what to do. Is usually the speed of action required precludes improvisation. This is the point I'm making, that the data that you need to doing those things can be collected with the help of the robots. So I'm going to show you this. So this is an Industry 4.0 work cell we're setting up at a ET lab at Polk State College. And I'd like to thank my engineering technology colleagues for helping me put this work cell together. So you see this work cell has two robots that you see in the front, and it has a PLC. I'll show you close, from close up to. So we have a PLC, has a screenless HMI, human device interface. It has a managed Ethernet switch. It has a relays that control the conveyor belt. It has a conveyor belt. And there's a limited, we can expand this work cell, of course, if you want to. But right now, just for demonstration, we put this together. We have as a temperature sensors. I want to see how you can collect data from work cell. 3 temperature sensors, you collected data from hotspot temperatures. you collect and you monitor. And the operation of this robot can be monitored and controlled remotely. If we had a Ethernet access, if I had internet access to through the college's Ethernet network at this work cell, I would be able to right now remote into it and show you this demo I'm about to show you live. But right now we don't have access to our college's Ethernet network here. We have asked, Dr. Tusi has asked for it and has been approved and it's in the works. But right now we don't have it. So I took a video of it and show you, but I show you what you would like if you basically I will show you for up close. You have a human machine interface screenless, and your computer, wherever it is in the world that it has internet access, becomes a screen for that HMI. You remote into this cell, and you have GUI interfaces that you make. You have to design it whatever you want. You can operate this cell from remotely and monitor it also. So you can see on the left side picture, that's the PLC of this cell. And then on the middle, you'll see the two relays that control the conveyor belt going back one way or the other. And the one temperature sensor is mounted on one of these relays because it's a power switches, they get hot. So you gotta monitor its temperature. And then the gray box on the bottom, it's a managed Ethernet switch. Without it, you can't have any Ethernet network. It's really an expensive device, but without this inexpensive device, you cannot have any Ethernet network because it manages the traffic on the Ethernet bus. It avoids collisions of data, so it's a necessary component of any Ethernet network. And then on the right side, you see the HMI. This is a screenless HMI. That is what you remote to internet. You have two Ethernet ports. You see one of them connect to Ethernet network of the college, and the other connect to the rest of the equipment. And that is, so your remote computer will act as a screen for this HMI. Yeah. So you design, when you remote into your work cell, you design what the graphic interface you want to interact with it. I just put something quickly together. There's a start button, a stop. There's a software, there's a scatter software. Different scatter softwares give you the ability to do this. But people have to design their own graphical interfaces. So I put a start button and a stop button and two numerical boxes that are going to monitor the temperatures of one of the relay and one of the work cell. And I put a temperature alarm there that if the relay temperature exceeds its maximum operating temperature, the alarm will start flashing. And you can have, it's not one page, you can have hundreds of pages because you have a large plan, different sector of it. You can design a graphical, what computer scientists call it GUI, graphical user interface. We call it HMIs, human machine interfaces. So you can design it for every section of your factory. You can design a graphic page. You can have hundreds of graphic pages. You can switch between the pages and control different parts of the factory from that page. Then critical components are collected still by even in this 4.0, because there's some component you need immediate action, like hotspot. That comes still by a scatter. There's no time for the data to migrate everywhere and somebody up the line decides that something is wrong. Something has to be immediate. So the critical component that is monitored by scatter software, such as this, alarm is issued immediately. And that just showing the two robots that we had. This uses the programming platform that we use to program the robots. It's nothing. Basically, it's not as complicated as people may think. If a robot does not have an artificial intelligence algorithm running, then it's pretty simple. You just teach it a point, and there's a P1, P2, and then tell it later on go to those points. So this is the demo I'm going to show you. Here you see how the two robots coordinate their operation. They're going to connect four with each other. But one takes its turn and signals the other one, I'm done. And then the other one knows that its turn is coming up and so forth. This is a collaboration of how cobots can collaborate with each other. And also the idea that you can remote into these things and control them. So that is the computer that you would see if anywhere in the world you could remote into it, and this is screen you could see. You see the start and stop button, you see the temperatures that you're monitoring. And you apply the start button on that software and the system stuff. I just show you a couple of back and forth, then I fast forward. I don't pick up back and I could have speeded it up too, and I put it at it's just what speed. Usually when you put these robots on higher speed, they have an overshoot, and they'll miss their target and come back. I'm gonna fast forward to the end, and I'm gonna stop it anytime I want. I can stop it by pushing the software button, and I stop. See if I can. I want to show you when I stop it. With stop it from remotely anywhere in the world, I can start it. I can stop it. I can monitor any parameters I want. Okay, so the temperature. The left side is, see the left temperature, you see that's the work cell temperature in Celsius. That's the environmental temperature. The other one, 30.8, that's the relay temperature. And then the maximum operating temperature of this relay may be 80 degrees Celsius. If that temperature reaches 80 degrees or higher, then the alarm will flash red. And presumably some action will be taken too. Right now, it's just a demo. Oops, sorry. So I'm pushing it. I'm going to stop it from that. I'll push the stop button. I guess I've already pushed the stop. Forward. Okay, so the takeaway, to summarize. So what is the takeaway of this presentation? Industry 4.0 is a growing and evolving movement to improve manufacturing efficiency and quality using the IIoT infrastructure. One of the main goals should be to minimize industrial accidents. If you go again to Industry 4.0 community, even the highest top-notch experts, you won't hear talk of this much. I have not heard anybody talk about this. One of the main goals must be to minimize industrial accidents because it has the ability to do that because all the data you collect, that must be a goal. And robots will continue the role in process automation with increasing involvement. No, not just so the role of artificial intelligence, machine learning is to prevent industrial accidents, and role of robots is will naturally increase because if you want more automation, there'll be more robotic involvement. Machine learning will use the IoT data to build models for improving machine performance and to schedule preventive maintenance. And industries that don't transform to Industry 4.0 will be unable to compete. So that should be obvious now, because the people who implement successfully and correctly Industry 4.0, they'll reduce their cost. They become so competitive that will be hard to compete with them. And the skills required to correctly implement Industry 4.0 will be in demand, particularly in data, in my opinion, in data analysis. But that's where the weakness is right now. We collect all this data, then we have to do something useful to it to better the operation. And that requires high mathematical skills in my mind, because you go to the cloud layer, sophisticated algorithms run on the clouds to develop machine learning software, machine models. Those skills are becoming very important. All other skills are important, but to me, data analytics is going to be one of the most important skills required for Industry 4.0. Thank you very much and for your time.
You had a couple of comments in the chat. First one was just to confirm that the attendees can have access to the slides from today.
That's up to Ernie.
Yes, so if you could send it
Yeah,
to
of
me,
course, yeah.
I'll send it out to all attendees. And then the question was, so what are the checks and balances on the AI systems? What are their self-check systems, collaborative systems?
Self-check in terms of going out of control. I mean, because we have very specific AI that in manufacturing, to me, will be in machine learning area. It will not be any AI that can reprogram itself. It's just machine learning that we collect a lot of input data, output data from machines, and we build these models that relates input to outputs. Is a very specific roles that they have. So I don't see any that you need to put checks and balances on the machine learning. If I understand the question correctly, that some people say AI is going to take control of things, but this is a very specific role. It's just programmed to do exactly what we ask it to do.
Are there any other questions?
Yeah, that was fascinating, Dr. Miri. And I know certainly one of the things that another professional development series that Dr. Eglin's working on, or has presented 3 or 4, he's on this call as well, is as we bring this equipment from being isolated onto connected and then onto the internet, obviously data security is really important. Maybe between you and Dr. Eglin can talk briefly about that.
Absolutely true.
Yeah, that is this more to see. That's why it took us a little bit longer time, and at this point we don't have it yet. A remote control to our Ethernet at college, but I did request and they agreed to provide it to us. If we had it today, probably we are going to have it next week, but a week late, too late. So we are following all protocol security system that we are not going to infect our college internet and jeopardize their security. Yeah, it's extremely important.
Fascinating. All right, well, great. Does anybody else have any other questions? Great presentation today. I also want to thank Teresa Potter, who does a lot of things behind the scenes for FLATE, but certainly does a lot of work on these webinar series as well. So thanks to you, Teresa, and certainly Dr. Miri, thanks to you for the great presentation.
The opportunity.
Yeah, and if we'll continue this conversation because it's important. Industry 4.0 is certainly the train coming down the tracks. I think everybody's going to have to get on board eventually. So we'll continue providing the education to students and industry and help companies make that transition. Thanks again for everybody. Everybody have a great weekend. And please sign up for the other webinar series, and we'll talk to you soon.
Thank you. Same to you. Bye-bye.